Okay, so the last set of notes talking about the theory of conservation of matter, I brought up photosynthesis and cellular respiration as applications of that theory. So I just kind of wanted to remind you and have you take a look at and refresh your memory. So remember, photosynthesis is carbon dioxide plus water makes the sugar for the cell or for the plant, and oxygen is the waste product. So that's why photosynthesis gives us oxygen. Cellular respiration is the opposite of that. Sugar plus oxygen. CO2 is our waste product. Water can be a waste product, and we create our energy. So that's why we breathe out carbon dioxide and water as a waste product, but we don't breathe out water. Okay, so what I want you to take a look at is these sixes in front of oxygen, CO2, and H2O. That is how these two processes support the theory of conservation of matter, and I'm going to explain that in our next section of notes. So our next section of our EQ is how do the products of chemical changes compare to the reactants? So now we're going to look at chemical changes. Remember, this goes with target 10, identify products and reactants of a chemical reaction and be able to apply the theory of conservation of matter when balancing equations. Okay, so remember, a chemical change produces a new substance that has properties different from the original. Cannot occur without some sort of energy, and we call that activation energy. So when we look at chemical changes, we also call them chemical reactions. We have to put them in equations. Chemical equations tell the chemist the reactants, products, physical state, and properties of the matter that's reacting. Reactants are the substances that exist before the reaction or the change begins. Products are the substances that form as a result of the reaction. For example, in this chemical change or chemical reaction, water and oxygen are the two reactants. They're what's doing the reacting. They're always on the left-hand side of the arrow. This arrow means change, and it requires energy. And the products is what's produced from the reactants, and we've got water. Okay, when you look at a chemical equation, you're going to see a couple things. Subscripts and coefficients. So subscripts are these tiny numbers down here. What that means, because the 2 is attached to the O, the oxygen atom, that means there are 2 atoms of oxygen bonded with 1 atom of carbon. The 2 is not attached to the carbon, so it has nothing to do with the carbon. It only has to do with the oxygen. It's telling you how many atoms of that element. And there are 2 oxygen bonded with 1 carbon. Coefficients, however, come before the compound. These are what we're going to be working with a lot and showing how it supports the theory of conservation of matter. Coefficients tell you, this 6 tells you how many molecules of CO2 there are. This tells you there are 6. So instead of just 1 CO2 molecule, there are 6 of them. Okay, so that tells you how many are reacting, how many of those molecules. Instead of writing all of these out, we put that 6 there. So it's 6 times 1. That's 6 CO2 molecules that are in the reaction. Okay, example. If we take acetic acid, which is vinegar, and we add that to sodium bicarbonate, baking soda, and we have some energy, kinetic energy that's going to cause those to mix together, we create sodium acetate, water, and carbon dioxide. The reactants are vinegar and baking soda. These are the reactants, vinegar and baking soda. Okay? The products, what's produced after these react, is the sodium acetate, the water, the carbon dioxide. Those are the products. Now, let's also identify some other things. Okay? Subscripts. We've got one here, 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 and here. So what this means is that there are 3 atoms of hydrogen, 3 atoms of oxygen, 3 atoms of hydrogen, 2 atoms of hydrogen, 2 atoms of oxygen. There are no coefficients in this example. Okay, so here we go. Conservation of mass or matter. Remember, matter cannot be created or destroyed, only changed. So, the mass of the reactants have to equal the mass of the products. Okay, so what this means is in a reaction, carbon dioxide and water are the reactants. Okay, sugar, water, and CO2 are the products. If the reactants have a combined mass of 10 grams, then the products have to have a combined mass of 10 grams. Because we can't create matter. We can't go from 10 to 20. We can't create matter. All we can do is change it. So if you look, carbon dioxide, the carbon and the oxygen are forming the compound carbon over here. All we're doing is changing that carbon into a carbon in a sugar molecule instead of carbon dioxide. This oxygen goes into an oxygen with the sugar. So all we've done is change the matter. We haven't created it. So that's why the mass of the reactants must equal the mass of the products. Okay, when we look at chemical reactions, we're going to start classifying those. A synthesis reaction basically has an element plus an element makes a compound. So here's your example. Iron plus oxygen gives iron oxide. That's a synthesis reaction. A really cute picture of this. Some of these I don't quite get, but we'll see if we can figure them out. A bird plus a worm. The bird eats the worm and becomes a bigger bird, because the worm, I guess, is in his belly. It's kind of cute. Decomposition. You start off with a compound as the reactants, and they get broken down into their elements, A plus B. Okay, so this is an example of a compound getting broken down into its parts. So the fun example picture that we get is we have an egg. If we break the egg down into its parts, we are left with a shell and a turtle that came out of the egg. Single replacement, and these get a little bit more complicated. Element plus a compound gives you a different compound with a different element. So here is our compound plus our elements gives us different compounds and then elements. So the example for this one's my favorite. So we start out with a couple, they're a compound, they're together, they came to the dance together. Then we've got the stud element over here. He steals the girl, so they become a compound because he's obviously a better dancer. And then he's left all by himself. He's the element. So that would be A plus BC gives me AC plus B. The last one's a double replacement. So we've got two compounds that get mixed up. So what I've shown you is we've got two compounds, and they get mixed up into two different compounds. So this one's a fun one. It's with faces and hats. So think of the hat and the face as forming a compound. So we've got a certain man with a hat, certain man with a hat. These are our two compounds, and we mix them up. This face now has this hat. That face now has this hat. And obviously that hat is too big for him. Okay, the last thing we're going to do, this is part of your practice. So I'm going to explain to you how we balance equations so that reactions support the theory of conservation of matter. So remember, we can't create or destroy matter, we can only change it. So whenever you balance equations, you can only add coefficients. Remember, coefficients are the numbers in front of the compound. Subscripts are these tiny numbers right here. We cannot add subscripts. Don't ever do that. Don't ever add these. Coefficients are the only thing that we can add. So I'm going to do the first one as an example, and then you're going to give the rest of them a shot. So if we look at this, we want to make sure when we look at a chemical equation, we want to check and see if it's balanced or not. So we want to make sure the reactants are equal to the products as far as how many there are. So if we look over here, Ag, which is silver, there's one atom of Ag over here. But look over here. There's a 2 right there. That means there's 2 atoms of silver over here. Well, that can't happen. We can't start off with 1 silver and create 2. That doesn't support the theory of conservation of matter. So that's not okay. So what we do is we add a subscript, and we can put a 2 in front of this AG. So now that's telling you that there are two AG two AG elements. And then over here we also have 2, so we're good with the silver. Those are balanced. Then we're going to look at the hydrogen. We've got 2 hydrogen, 2 hydrogen. We don't need to do anything about it. Oh, there's a typo. This should be an O. Forgot about that. And that's an F. 1 oxygen, 1 oxygen. So to balance this equation, all we had to do was add the 2 in front of the silver so that they would balance. Okay, we'll do one more. We'll do the next one. Actually, let's see. I don't want to. Okay, so we're going to do the next one below. We're going to do number 2. So let's look at our carbon atoms. We have 1 carbon atom, 1 carbon atom. We're good. 4 hydrogen atoms, only 2 over here. So I got to figure out how that's going to work. I'm going to put a 2 in front of here. Okay, because 2 times 2 is 4. And if I had another H2O molecule, because that's what that 2 represents, I have 4 hydrogen atoms. Okay, so 2 times 2 just means 2 H2O molecules. So now my hydrogens are balanced. So 4 hydrogen over here, 4 over here. Now let's check our oxygen. I have 2 over here, okay, but then I've got 2, and then, when I add a 2 there, it doesn't just affect the hydrogen, it affects the oxygen. So I have a total of, I have 2 oxygens over here, because 1, 2, plus 2. So I have a total of 4 oxygen atoms over here. Well, I only have 2 over here, so I've got to add a subscript. So I'm going to add a 2, because 2 times 2 is 4. Now I have 4 oxygen, and that one is balanced. Okay, so what you're going to do for the rest of these, you're going to balance them. And so the first thing you're going to do is just go through each element. Are they the same? Mg, O, O3. There's a problem. Then you're going to have to figure out how to balance it by adding only coefficients. Oh, and I forgot one thing. Sometimes you guys like to do, well, let me fix this and I'll show you. Okay, sometimes I've seen students try to add a coefficient in the middle of a compound. You can't do that. Okay, you can only add coefficients in front of the compound. You can't mess the compound up. Okay, so the coefficient always goes in front of the compound. Okay, another thing that I've seen that's been done before is people have added coefficients at the end. That's not where they go. Okay, that would be almost like adding a subscript, so don't do that. When you add a coefficient to balance something, you need to make sure you add the coefficient in the front of the compound. Okay, so now what you're going to do for the rest of the assignment, you're going to balance the rest of these. I will tell you this, do number 4 last. Number 4 is the hardest one, so do this one last. Okay, don't try to do that at the very beginning, do it last. I should have put it at the end, but I forgot. Okay, then you've got question 8, read it, and you're going to have to balance it. You're going to have to set up the equation and balance it. 9 through 12, you're going to classify the types of chemical reactions. You're going to put synthesis, decomposition, single, double replacement on these. Okay, and then 13, you're going to read this, apply the theory of conservation of matter, and solve it. Okay, so hopefully you should be able to do the practice after going over these notes. And remember, this is Learning Target 10. You should be able to identify products and reactants of a chemical reaction and apply the theory of conservation of matter when we're balancing equations.